My name is Amanda Hinchman-Dominguez, and I'm a software engineer at Yellow. So today, I'm here to talk about the journey that I started about a year ago when I accidentally stumbled on Kotlin. So while we explore metaprogramming in an academic sense, we can go ahead and take these observations that we will find out together, and we can apply them to our own world. So what I want people to take away from this talk is to not box themselves in with the way that we currently approach problem solving. We're going to use TornadoFX to explore the Kotlin language and the features that Kotlin possesses as a functional paradigm to discover metaprogramming in a way that no other statically typed language has previously accomplished. Any significant application works with data, and providing a means for users to view, manipulate, and modify that data is not exactly a trivial task for user interface development. Fortunately, TornadoFX streamlines many of these JavaFX data controls and other UI components such as table views, data grids, data visualization charts, and of course, I had to throw up Thomas Neald's traveling salesman problem. So if anyone attended his talk, I was very pleasantly surprised to see that he used that for his mathematical modeling. Really, really cool stuff. There's a lot of really cool TornadoFX projects out there. And of course, you can always check out the TornadoFX Slack chat. It's a lot of fun. So, what is TornadoFX? TornadoFX is a JavaFX framework that's leveraged in Kotlin for native development. It's actually one of the first frameworks that I learned in Kotlin, and I fell in love with it immediately. It's quite amazing. It's not widely advertised because it's typically used for internal business applications, but it's very, very easy to get that quick spin up and that quick satisfaction. So we have some code over here for list views, and what's quite amazing about this is that what's amazing about this is that within 10 to 12 lines of code, we have a list view in which a user may interact with it. So this actually blew me away the first time I saw TornadoFX, because normally in JavaFX, to accomplish the same thing, you would be required to have at least 50 lines of code. And you can get really lost in that syntax. So I was just really relieved when I started TornadoFX to not be writing so much code. Edvin Seisi created this framework a couple years ago. The project was originally inspired from an early HTML builder project that was back in Kotlin beta back in the day. And it's really, really amazing because you can use builders through functional declarations to be able to create these controls in a much more streamlined fashion. What this means is that you have a lot less verbosity, and it's very, very easy to learn. So when I first started, I was just relieved to not be writing so much code, but then I started spending time with TornadoFX, and then a lot of people in the channel started showing me really cool tricks and tips, and I thought, wait a minute, these are concepts that I had initially rejected when I was learning Haskell and Ruby. So I thought, I'm using TornadoFX, but Kotlin has all these amazing functional features. So if these features are comparable to functional languages such as Ruby, Haskell, Clojure, Scala, then is it possible that Kotlin conferred a metaprogramming as a statically typed language? Why am I talking about metaprogramming? Well, Kotlin happens to be a functional language. Up here, I have a couple characteristics of functional languages. Of course, there are more, but I feel like these three are the ones that functional purists can most definitely agree on. So, first pillar of functional languages, functions are treated as first-class citizens. This means that in a functional language, the language treats functions as a parameter. The second pillar is that there are no side effects for functions. So functions are black boxes that takes an input and then spits out an output, but it doesn't necessarily affect the program in any way. If I have a function that's an addition function, and you have 1 and 3 and you get out 4, that 1 and 3 is not affected. And then, of course, we have metaprogramming capabilities in a functional language. So normally when we think about metaprogramming, it's code that writes code. In the academic community, metaprogramming can be defined as programs that treat programs as data. So that means that programs have the ability to read, analyze, or transform those programs. So what does this mean in the real world? No, metaprogramming is not going to take away our jobs. Rather, it can be used to make our lives a lot easier. So, a little bit of a story time. About a year ago, I was working in sales enablement, and there were about 3 developers handling 50-plus business-to-business clients. So we're talking about BNY Mellon, SunTrust, Boeing, Lockheed Martin, whatever. And as if that wasn't enough work, we were also required to create live demos for every prospective client that came through. And the problem was, it took about 2 to 3 hours to spin up a library every single time. And being the lazy person that I am, I really hated that. And I thought we needed an automated solution so I don't have to do it anymore. And of course, there were so many client fires that, that didn't happen. But I went ahead with it anyway. And this is actually an open source solution on GitHub. It's called TornadoFX, drag and drop tiles and FX. So this programmatic solution allows people to generate XML via a drag and drop GUI. It's really cool, right? I mean, I thought it was. But this brings me back to my earlier point that metaprogramming can help us solve our everyday problems. So what kind of problems are we trying to solve exactly? Let's go ahead and analyze another application that will help us define the nature of these problems. When I was in school, the first language that I learned was Scheme. And for those that are unfamiliar with Scheme, it's very similar to Lisp. It's a functional language. And the reason why the computer science department decided to have that as the first class was that it evens out the playing field. So it didn't matter if I didn't even know the basics for coding, or if some other guy had been coding for 5 years, we equally had a bad time. So, yeah, no, a lot of us were up at 3 a.m. just like crying like we don't belong here. And anyway, we're going to repeat my first year nightmares and talk about image processing. I really like image processing because it can help us visualize algorithms in a way that's tangible. And it can help us develop computational thinking without having that computational background needed. So if we said that black has the value of 1, and white has the value of 0, we can apply binary operations to these pixels. And of course, 1 and 0 gets you 0, 1 or 0 gets you 1, and so on and so forth. So we call these primitive filters. We can start with the OR filter, in which we have 2 images, and you take the summation of all black pixels, and you get a very, very demon-like looking lady. And of course, that's the summation of all black pixels. The remove means that you have the difference of all black pixels from one image, and you remove it from the other, and that's the result. So then we can get a little crazy from here, and we can get a top edge in which we take the original image and we shift all the pixels up by 1. Of course, you can do the same with left, down, whatever, but we're going up, and we're going to compare that with the original image. Then we're going to inverse the result of that to get a totally different image. So we start playing around with these filters. And what I want to do is compose a horizontal edge filter. And what that means is that I take the top edge of an image, the bottom edge of an image, I'm going to OR the result of that and then inverse it. So I write that code, and I was really proud of myself because it was only 3 lines. When I broke down a complicated filter into smaller primitive filters, I was able to write this code cleanly and concisely, as we always should. The problem is that every primitive filter that I call loops through every respective pixel of an image, and then it creates a new image every single time. So what this means is that I have clean and concise code, but it's extremely poor on performance. We're creating all these new images and we're throwing it away. What's the point? I'm going to go ahead and rework this problem so that we have something that is not poor in performance, so we don't get data segmentation faults, we don't get crashes from overusing our memory. So I rewrote the problem, and instead of looping through the pixels a million times, I loop through it only 1 time, and I apply the filters all at once to every single pixel. So we have 1 loop, and then we're going to go ahead and OR the result, and we're going to take the AND of 1 and the NOT of 1, and I noticed that some people are actually leaning in to read this code, And that's okay, because now we have another problem. This is what I called tangled code. In order for any of us to maintain, debug, or refactor this code, we're going to have to untangle it in our heads, write some code, and then retangle it back and hope that it works. It's kind of a pain, actually, and I'm sure everyone has dealt with this at some point in their jobs or, their personal work. At this point, I've sacrificed readability for memory optimization. And because of the natural tendencies of, all languages, whether it be object-oriented, imperative, functional, we come across on a daily basis having to sacrifice one domain design decision for another. And this is what we call cross-cutting. So, software engineers have come across common problems in the industry, and then they've also come up with generalized solutions. So an example is generalized architectural solutions. So we have our MVVM, our MVC, MVP, whatever it is that you use. Similarly, we can generalize problems that frustrate us as developers and boil cross-cutting as a two-level abstraction in which we have a representation of concerns. So we have our sources and our targets. And in this particular example I described previously, maybe my concerns were that I had clean, concise code, it's very maintainable, but it's also memory optimal. But it could mean other things too. So it might mean that maybe you have like a blog site and you have subscribers that you care about, and you have a notification system that you care about. It doesn't matter what it is, it's any form of abstraction that you want to make it at. And then of course, your targets are the software artifacts that addresses those concerns. So you get cross-cutting when you have scattering and tangling, and what that means is that you have sources that map to multiple targets and multiple targets that map to a single source. Combining those two gets you spaghetti code. In real life, this might mean that maybe the rate that we parse documents is not as fast as we thought it was because we have really inefficient algorithms. Or maybe we have a really hard time debugging the code that we're trying to fix because the architecture is really convoluted and the data flow is different every time. Maybe there's a God object that communicates with the entire system when it really doesn't need to. Metaprogramming is how we approach dealing with cross-cutting in whatever form or abstraction level that it might be. We've defined what metaprogramming is supposed to solve. We should go ahead and talk about the very common forms of metaprogramming. So these are like the most common. You have wizards, which is similar to monkey patching. I'm not a fan of the term, but I found myself using it a lot, so that's probably what I'm going to be using. We also have aspect-oriented programming, and we also have domain-specific languages. So in the last month, I switched over to the Android team, and my manager was like, paperback or PDF? And I'm like, paperback. And he slams down the big Nerd Ranch Android programming guide, and I read all 700 glorious pages of it. And this, for anyone who's not familiar with Android work, this is Android Studio, and this is actually a really, really popular feature in which you have the design and the text. And the idea is that you take your UI components and you drag and drop it to the view that you're trying to design. I'm more of a CLI person myself, but some people really love this feature. This is an example of monkey patching, because when you drag and drop those UI components, what you end up getting is generated XML code, which of course is like revealed in the text area. The project that I made earlier is also an example of monkey patching, and I thought, I was so proud of myself. But it turns out it's actually the lowest form of metaprogramming, and the reason for that is that it's very error-prone to user input, and also the generative coding that you create is very limited to markup, so that could be XML or HTML. Nothing wrong with it, but it's good to recognize these things. Then we have aspect-oriented programming. So this is how Java and C marries object-oriented programming with metaprogramming. AOP separates concerns as a higher-level abstraction to be able to weave those aspects into a more compatible coexistence. So coming back to the image processing problem, there are actually a lot of ways that we can pull out those abstractions to address the problems that we kind of ran into with the horizontal edge problem. There are no right or wrong answers, but I decided to optimize data flow for primary filters by implementing memoization. So of course, memoization is not a feature that Kotlin has, but it's not very difficult to implement it ourselves. In computing, memoization is an optimization technique that's used to primarily speed up computer programs by storing the result of the expensive function, and then you return the cache result every time you see those same inputs that you're making. So this is really, really nice because I have this memoize class function in which the parameter that we're taking here is essentially a function, and we care about the type that we're putting in, and we care about the type that comes out. Yeah, to be fair, when I first saw this, I was really, really overwhelmed, and that's why I wanted to take a step back and actually look at this, because this is what makes Kotlin really powerful. So we have a function as a parameter, and we have a mutable map. Excuse my wonderful pointing skills. So we have a mutable map, and then when you call the invoke function, you're actually overriding the main constructor of the function application. In Kotlin, they call the form a, with the parentheses, and it's converted to a.invoke. This is actually equivalent to the apply function in Scala. So we call the invoke function, which means that we're simply going to execute the function that we're putting in, and then we're going to save the result in the return values, get or put. We're going to save that result, both the input and the result, into the hash map. Then we're going to actually customize the way that we call it, so we're simply going to attach the function. I have my horizontal edge down here. We're going to call memoize, and the result of that is that every time I put in a pixel or 2 pixels and I execute a function, but I've already recognized the inputs, there's no reason to pass that data through again and make unnecessary calls. So the result is that we choose not to pass data through a primitive filter if we already know what it is. This is aspect-oriented programming approached in a generalized fashion. We simply pull the abstraction layer out, and it helps us optimize the data flow. Java approaches aspect-oriented programming with annotations. So this is something that's very, very common for a lot of Java developers, is override annotation. Override sends a message to the Java compiler and then checks if that method is properly annotated within overrides. So we use this quite often. When I first started I did Java development for a long time, and I never actually looked into what the stuff actually meant. But it's really interesting. So the support for generic types came around roughly the 5th version of Java, and it gave the Java Reflection API newfound abilities for dynamic introspection. So that means that it now has the ability to crack the hood and look at the code underneath to see what's going on. So reflection is a programming technique that allows us to examine and even modify the structures that we're looking at runtime. So the Java Reflection API allows us to look at what class am I, what methods do I possess, what am I returning, what modifiers do I have for those member classes. There are other popular frameworks and libraries that use it, and it's not just Java. If anyone works with Spring Boot or maybe even JAspect, they do have rather powerful approaches for aspect-oriented programming using annotations. As with a lot of things with metaprogramming, I just thought, this is too much magic. So we're going to go ahead and debunk and kind of look into how annotations work by looking at a customized annotation that I created. It's not, there's really 3 ingredients for creating an annotation. You declare your interface, and unlike a traditional interface, you don't need to have an implementation, and you don't need to inject the annotation designated. So this is what you use to declare the annotation itself. I name mine transaction. The most important part is specifying the retention and the targets with it. So when you specify the retention, you actually determine how long the annotation is kept for, from source code time all the way to compile to runtime. So in my example, I chose runtime. And then, of course, the target specifies where that annotation is going to live. So that annotation, I stuck mine to any methods, but it can be applied to classes or fields. And then, of course, the elements are the attributes for your annotation, otherwise known as parameters. So I went ahead and created my annotation, and I applied it to a class of bank transactions. And essentially, when I run this class at runtime, what I'm going to get back is I know that a withdrawal happened, I know that a deposit happened, I know that a transfer happened. So writing annotations can be really short and quick, but as with many things, much time can be consumed in the design itself. Runtime means that the annotation carries through to the JVM, which is primed for reflection purposes, but this is not a particularly useful example. Unfortunately, it's rather very static, but frameworks like Spring Boot and uses JAspect and interceptors for more complicated tasks like auditing and logging. I kind of talked about how this is a really static example. We've achieved reflection with Java. It's an essential component for code generation, but the nature of the Java language provides a lot of difficulties for true metaprogramming. As a statically typed language, Java really only allows a very, very limited set of reflective capabilities. So if you get nothing else out of this, I want you to take this home with you. The reality is annotations are only a form of metadata, and it only provides information about the program, but it doesn't necessarily modify the behavior of the program that you're attaching those annotations to. You can also use an annotation processor to be able to generate code with compile time annotations. But unfortunately, the shortcoming with that is that you kind of have to designate where those annotations are being put. So you have to do all this prep work before you can do anything at all. Those are the issues with aspect-oriented programming that I have when it comes to Java and annotations. But we should also talk about how statically typed languages and true metaprogramming doesn't actually play very well together. And there's a couple reasons for that. So when you have true metaprogramming, you generate code, but there's no compile time that comes with that code. And statically typed languages really depend on that because that's how we get our type safety. So that's one challenge that must be overcome. And then, of course, true metaprogramming doesn't respect encapsulation. If you have code that's looking at your code and you're generating code, it's not going to care that you've designated private and public classes, and that's kind of a pillar for for object-oriented programming. So another problem in which you must sacrifice one domain for the other, and that's that's the difficulties when you're trying to achieve true metaprogramming with statically typed languages. But there's another issue in which statically typed languages tends to overcomplicate the problem you're trying to solve. So if you're trying to create metaprogramming, there's an issue of you trying to simplify that problem. And I like to demonstrate it with another problem that seems to be food related because apparently I was very hungry when I made this presentation. So you need to salt your food, you're at a dinner party, and it's totally out of your reach. But if you kind of get up and you weave around all the dishes and you try not to knock over any glasses of water, whatever, and you don't make a scene, you don't get food on yourself, you're good to go. That is the nature of imperative languages. It describes the exact sequence of steps to perform an operation. And then, of course, there's the declarative approach. Pass the salt, please. So what that means is that you describe the exact result, and then you leave the execution details to the engine that interprets it. So this is great because all necessary optimizations are implemented once, and your execution is far more efficient, and the result is that you have reduced bugs. You don't have to worry about the possibility of knocking over plates or getting food on yourself because you asked for it. Kotlin happens to leverage declarative programming, which is a key characteristic of the third form of metaprogramming, domain-specific languages. We can't talk about domain-specific languages without talking about general-purpose languages. So, general-purpose languages can solve any problem. This is Java, this is C, this is Kotlin. DSLs, however, focuses on a specific task and then forgoes any functionality that is irrelevant to that domain. So we can think about SQL, we can think about regular expressions. So they can manipulate the database or text streams, but you can't use them to develop an entire application. DSLs the thing about them is that they're really, really difficult to combine with a host application that uses a general purpose language. So usually what ends up happening is that you have to store that DSL into a separate text file or a string literal. And what happens is not only is it difficult to combine, but you get a lot of overhead. Kotlin, however, contains the ability to create internal DSLs. So it's not a fully separate language, but rather a particular way of using Kotlin while retaining the key advantages of DSLs. The ability to create higher abstractions with Kotlin is also a feature that's comparable with Haskell. And the great thing is that TornadoFX really takes advantage of declarative programming, and this is actually a really great segue for us to be able to kind of go into some features I really like about TornadoFX. So while you can create plain CSS style sheets in JavaFX, TornadoFX provides a way to allow you to have an option to bring type safety and compiled CSS to JavaFX. Type-safe CSS is a prime example of DSL creations using type-safe builders. Builders actually came from the Groovy community, where the idea is that they provide a way to create an object hierarchy in a declarative way, which is really, really convenient for generating XML or laying out UI components. So in this example, there's actually not too much going on in here, but you can designate your button, you can designate multiple types, and then you apply a certain function or a CSS filter to them. So Kotlin uses the same idea as the Groovy community with builders, except in Kotlin they're type safe, so it makes it really, really convenient. And this is achieved with Lambdas with receivers. Lambdas with receivers are a very, very powerful Kotlin feature, and it allows you to build DSLs with structure. So rather than using external templating or markup languages, Kotlin internal DSLs has the ability to reuse code and then create abstractions with higher order functions. So I also thought this was a lot of magic, and it really helps to just go and look into the source code for TornadoFX, and we can see how this is achieved through Kotlin. So in this code, this is a function taken from the CSS class in TornadoFX. The idea is that you have a selectable, which takes a void function, and it allows you to attach CSS operations to a particular element. So we can dig into this a little bit. We have the operator, and normally it marks a function as overloading an operator, or in our case, it implements a convention. So we have this invoke method in which we apply a function as a parameter, and it allows us to be able to use it as block code. And in Ruby, you can facilitate higher order functions with yield, which involves passing a block to a method. So like Ruby, Kotlin treats functions as first-class citizens. So that is a pillar of functional programming that we've identified earlier. In Kotlin, the equivalent of block code is known as Lambda functions. So that's indicated by the pattern A, B goes to C, or A dot B, in which the B is a parameter, goes to C. So here, the special type CSS selection block is called the receiver type, and the value that's passed to the Lambda unit becomes the receiver objects. And then unit, of course, in Kotlin simply means that you're returning a void function. Instead of passing the object as the argument, you invoke the Lambda parameter as if it was an extension function. So this is really nice because we can invoke it without any qualifiers. We can't talk about passing around functions as parameters without talking about reified generics. Generics on the JVM is normally implemented through type erasure. So what this means is that when you use a generic type and it compiles, it's not preserved at runtime. So just as in Java, Kotlin generics are erased at runtime. So this means that the instance of the generic class doesn't carry information about the type arguments that's used to create itself. As a workaround, Kotlin made it so that the compiler will take the inline function and the function of the Lambda that's passed to it, and then it copies that bytecode into every single place where the function is called. And this is really amazing because when the function is called, the compiler knows the actual type, and it modifies that generated code to use to the corresponding class directly. So reified generics are used as parameters in functions, and it allows you to preserve those types at runtime, which is how we're able to pass around functions as parameters. So this brings me to my another favorite TornadoFX feature of mine called scopes. So I created a really, really fun application, and we did this fun workshop in Chicago where we made a cat scheduler app because you can't keep track of the cats they have to look after. Another one of my great 3 a.m. ideas. The idea of scopes is that when you use inject or find to locate a controller or a view, by default, you're going to get back a singleton instance. So whenever you locate that object in the code, you're going to get back that same instance. Scopes provide a way to make a view or controller unique to a smaller subset of instances in that application. So in this example, I had an edit action which created a new scope. It injected the cat schedule model configured with whatever selected user that I selected, and then puts it into that scope. And then the editor dialog retrieves the instance of that scope, so I'm using the very, very same instance of the model that I'm working with. And of course, you can edit it, and then thanks to TornadoFX and their ease for like rebinding and listening for those changes, that change is immediate, and there's not a lot of code required for it. We're going to look into the TornadoFX source code to kind of see how that's accomplished. So this is coming from the TornadoFX components class, in which you have a find function that's available to a particular view or controller, and you have the option to pass a scope into it. And I found this, and this is actually coming from some TornadoFX like chat, trying to figure out how scopes work. So I found it, and I saw the bottom one. I'm like, oh, okay, I get how that works. But the top one, I didn't know what was going on because that seemed to be like a Java way of thinking. So I kind of pinged Edvin, and I was like, Edvin, what's going on with this? And he's like, oh, it's really funny you bring that up, because when he first started writing in Kotlin, he came from a Java background, like a lot of us did, and he essentially was writing Kotlin in Java, or Java in Kotlin. So we're going to go ahead and break down both sides, like just to compare how generic types are used in Java versus generic types in Kotlin. So the first version is how Edvin initially created the find function before he realized the possibility of passing the type as a type parameter as opposed as a class parameter. So he was thinking in Java as opposed to Kotlin. In Java, if we try to get the class of the type parameter t, the compiler is going to complain, and it's going to say something like, can't use t of the reified type parameter, use a class instead. So normally, as a workaround, the class of t can be made as a method parameter, and then it's used as an argument for find. This works, and it's a really common pattern for generics in Java. With the second version, we have the reified type parameter, which can only be used with inline functions. So when the inline function is compiled, its bytecode along with the bytecode of the Lambda passed to it is inserted directly into the code of all the calling functions to prevent any overhead. The effect is that you can pass functions through parameters in a way that type arguments cannot be erased. Thus, that's what gives us the name reified. It can't be erased. So this is great because you almost never need a specific subtype of the scope. You just inject your object or model or whatever into that scope, and you can pass it around as the same instance. So if we kind of look back at it, I kind of feel like using the Kotlin way of passing around generics is quite easier. Okay, I'm going to take a big breath because that was a lot of information to go through. Okay, so we've covered how metaprogramming is a solution to crosscutting. We've covered common forms of metaprogramming as well as their shortcomings. And then we also kind of talked about how TornadoFX leverages Kotlin to be able to streamline certain features in JavaFX. So what does this all mean? Why am I talking about this? The reason why I'm talking about this is because I'm attempting to do something really, really brave or really, really stupid, and I haven't really decided yet. When I created this application a while back, I didn't really understand how to use serialized custom objects. I do now, and I'm still not a fan of it. But what I ended up doing is creating my own event filters based on mouse clicks, and I ended up micromanaging my own drag and drop. So the problem with that is that it was rather buggy for a while, and it made it really difficult to debug and whatnot. So I thought, wow, I really need testing for this. But I don't know how to write tests. So I went around asking, what makes a good UI test? Like, what makes a good test? And I got a lot of different answers from people. I got a lot of different frameworks. And it kind of seems like testing is very early in its stages, and it's not quite a science yet, which is fine because I also don't know. So I thought, what if I made an application in which I can scan my components, and I put in my TornadoFX application, and it's going to look at all the data controls that I have, and then I can generate tests from that. It turned out to be a very hard problem. This is about as far as I got. It's also open source. It's called TornadoFX Suite. And what I'd like to do is get to the point where I have, I see a form, and maybe I want to ask for things like, is there a contract for this? I only accept these kinds of values for these kinds of inputs. Or if I'm a button, am I enabled if a certain state is dirty, and so on and so forth. We can apply this for more than just generating tests. So when I originally thought of this problem and I thought about a solution to it, I was only thinking, I don't know how to write tests, I'm very lazy, and I don't want to write tests. There were challenges to address, which we kind of identified a little bit earlier. One, true reflection doesn't respect encapsulation. So this turned out to be problematic because the fact that we're using private and public, I still kind of wanted to respect that. And then also, generating code at runtime means no compiler type checking. And of course, we wouldn't want to forego that. So what I ended up doing, this is kind of where I came from. I did not design this solution from the top down. This was more of a POC than anything. I ended up, use the TornadoFX to create the GUI, upload the project. I read the Kotlin files with AST parser. That's an abstract syntax tree. And that actually turned out to be very difficult because I ended up having static types even for my ASTs. So it wanted to know there's like a node and a function and whatnot. And I just thought, wow, I almost wish I had a dynamic ability to recurse down into these potentially infinite trees without caring what type I'm looking at. So I kind of did a workaround and created like a JSON tree object from that. And from there, I was able to locate those UI components. That's kind of like where I'm at, and we're gonna like write some tests, but there's more to that. Only a couple weeks ago, I realized what the next like natural progression of metaprogramming is, and that's machine learning. Actions are something that's influenced by an environment. So this is what testing does. Testing is the active process of exploring that environment and then determining how it reacts to various conditions. So testers learn from those interactions. So if we're going to talk about generative machine learning, we're going to say it's a tool that does testing, but by definition, it's going to learn. So we start off making all these tests. We have these UI inputs, and we're going to say, OK, we're going to create a permutation of all those interactions that we possibly couldn't do ourselves by manually testing. So we start with that, but what if we started collecting data from those generated tests, and then other people started using those tests? Eventually, we can find out certain predictions. We can find reinforced learning. So we could say, if a person is writing a certain UI component and they start trying to write tests, maybe we could say, OK, as a machine, I've recognized a lot of these bugs in the past. I think this is a test that you ought to use. Or maybe it could even go as far to say, did we choose the right UI design by by collecting all these data points? So this is something that I'm really, really excited to continue my research about. This is where I am in my research, and to be honest, when I was invited for this talk, I spit out my coffee because this is very early in its stages. But like I said, it's open source. The code is incredibly messy right now, and I need a lot of help with it. So it's currently embarrassing, but I think there's a lot of potential for something much larger. And of course, I wanted to say special thanks to a lot of people that are much smarter than I am. A lot of these people reside in the TornadoFX channel, and Thomas Neal is here today, of course. Wonderful guy. Super smart. And of course, thank you all for coming to my talk. As I mentioned before, this is a work in progress and my research is far from over. And most importantly, if you're interested in using TornadoFX, whether it's for personal use or maybe you want to do things at work or you want things to happen for you as opposed to you doing repetitive tasks, because that's where this all stemmed from. There is a TornadoFX channel on the Kotlin Lang Slack, and it's very, very welcoming. Literally, if you put in a message at 3 a.m., 5 people will answer you. It is an amazing community, and the fact that I only started Kotlin a year ago, and now I'm here, I think this is just a true testament to how amazing Kotlin is as a language, and of course, as a community. And of course, these are some of the noted projects that I mentioned throughout my talk. You're welcome to take a look at any of them. So thank you very much.